Welcome to Foundations 30. This is lesson 3 where we're going to kind of interconnect probability and odds. So lesson 1 was about probability, lesson 2 was about odds, and in lesson 3 we're going to bring the two of them together. So basically just being able to go back and forth between the two of them. So question number 1 says, research shows that the probability of a pregnant woman selected at random having twins is 1 out of 32. Determine the odds for and against having twins. So I'm asking you the odds for having twins, the odds against having twins. Okay, so remember that if I want the odds in favor of, then I would do, so odds in favor. So remember we have two ways of doing it. I could do the probability of having twins to the probability of not having twins, right? So if I did it that way, you could go 1 in 32, because that's my probability of having twins. Then the probability of not having twins would be all of the other cases, so 31 out of 32. And then essentially you can just cross off your denominators, so it becomes 1 to 31. So you can do it that way. You could also just think about the number of twins to the number that are not having twins. So out of my 32, there's 1. And then all the rest of them would not having twins, so that is 31. So whichever way your brain works, you can either think of it as probabilities or odds, or numbers is totally fine. So that would be my odds in favor is 1 to 31. The odds against is really just a reversal then, right? So it would be the number not having twins to the number that are having twins. So out of my 32 people, there's 31 that are not having twins, and my odds against having twins would be 31 to 1. Okay. Number 2, a computer randomly selects a university student's name from the university database to award a $100 gift certificate for the university bookstore. The odds against, so this question is giving me odds. The odds against the student being male are 57 to 43. Determine the probability that the randomly selected university student will be male. Okay, so if it's giving me odds against, and they're saying that the odds against are 57 to 43, that means that this is the not males, right? Because it's odds against, and this is the males, okay? So determine the probability that they will be male. So the probability that you will be male is the number of males, right? The number of favorable out of the total number. Okay, so the number of males from my odds statement is 43. And the total number, well, you're either going to be male or not male. So it's going to be 57 and 43, which adds up to 100. So there's a total of 100 people. So 43 out of 100 is my probability that you will be male. Okay. To compare two sets of odds, okay, I'm reading number 3 here. To compare two sets of odds, you should make them equivalent. It's like creating equivalent fractions, meaning you need common denominators. So it's the same idea here. So if I want to make 15 to 2 and 8 to 5 equivalent, I need to set them, basically these second numbers, equivalent to one another. So think of a common denominator for 2 and 5 would be 10. So I'm going to multiply this statement by 5 in both terms and this one by 2 in both terms. So these become 75 to 10 and 16 to 10. Okay, so sometimes if you're comparing two situations, you might need to have equivalent odds. So a hockey game goes into a shootout, and the coach has decided which player should go in first for the shootout. He wants to use the best scorer first, so it will be based on the player's shootout records. So player 1, here's my information. Player 1 has 13 attempts and 8 goals scored. Player 2 has 17 attempts and 10 goals scored. Write the odds in favor of each player scoring as a ratio. Okay, so for player 1, the odds in favor of him scoring. So I want to know then it would be the number of scored, like the number of goals, to the number of not goals, right? So for player 1, he has scored 8 times, so it's going to be 8. out of 13, so that means 5 times he did not score. Player 2, okay, same thing, number of goals to number of not goals. So he scored 10 times out of a total 17, which means he didn't score 7 times. Write the probability of each player as a percent. Okay, so the probability of player 1 getting a goal is 8 out of 13, and we want that as a percentage. So you take 8 divided by 13 and times it by 100, and you get 61.5%. The probability of player 2 getting a goal is 10 out of 17. So when I write that as a percentage, 10 divided by 17 times 100 gives me 58.8%. So which player would you choose to shoot first? Well, I would probably choose player 1. Okay, because they have a higher probability. And which is easier to compare, probability or odds? Well, clearly here, like probability as a percentage is the easiest, right? Because even if you look back at the probabilities when they were fractions, those are tough to compare. These are tough to compare. You could create equivalent odds. So for example, I could turn these into, say, 35s. If I just go back to my odds for player 1, I could have said that he would be 56 to 35 if I multiply both of those by 7. And if I go to the other guy and multiply him by 5, that would go 50 to 35. Now I can compare those odds a little bit better when they're equivalent odds. This guy is going to score 56 times, and this guy's only going to score 50 times. So player 1 has got better odds, but its probability as a percentage is probably the easiest way to compare. Okay, so I want you to go ahead and practice some questions on your own.